just said to me, I don't think that we should use SageMaker for this. I think we could write something ourselves that would do the same job. And that made me think, oh, hang on, I thought SageMaker was artificial intelligence. Okay, so artificial intelligence is where we use a computer to try and simulate natural intelligence, which is what comes from a brain. So it's a computer trying to do something that a human brain normally is used for. Then when you said, well, artificial intelligence is all about weighting, I-E-W-E-I-G-H-T,
Yes.
I thought, wow, that was quite new to me.
SageMaker is incredibly complex and it's for classification. When we're really looking more for similarities and potential suggestions, we haven't put any of the data so far into SageMaker, so we have no guarantee that the data will work with SageMaker. I've put it into a form that SageMaker could understand, but we can't tell SageMaker, I want stuff like that.
This sounds to me as though it's just basic programming, you're creating an application, you know, you might download some modules off GitHub or something like that.
Yeah.
Is that artificial intelligence, or is there a...
Well, when the computer's changing its own weights, we don't have to have any input. We can just say, you got that right, you got that wrong, and the computer then takes that and builds on it.
And that's what the training is doing?
That's the training, yeah.
We could also make this, if we wanted to, we could make this a public.
Yeah.
So any company that does B2B email marketing could take
Yeah,
what
we can
learn
open source it, yeah.
if we wanted to.
If we want to.
And could we do that with SageMaker?
We could open source it, but it's useless unless they have a SageMaker account, they've got the instances, they've got the S3 bucket. Meanwhile, with ours, they can just put in a CSV.
Okay, let's do that then. This is the beginning of day 2, and Joe and I are going to just have a quick recap on what we did yesterday, what decisions we made. Just to recap on yesterday then, Joe, what did we do?
So we looked at pulling down information from contact enhance and passing that into a format that we can then run our algorithms on.
So Contact Enhance allows you to put an email address in and find out information about those businesses.
From contact enhance is a CSV file. So I've written the code to pass that into a object that the computer can understand, and then every field for each person now has a differencing algorithm to say how different is it from that field on another person.
Right.
So you can look at the SIC class, the turnover band, the employee band, and it will give a difference value based on how far away they are from each other.
And what's the importance of a difference value?
So then we can take that difference value and to calculate the difference between two people, we'll go through every field and calculate the difference, and then sum that all up. And the bigger the number, the more different they are.
What's your plan today?
Today the plans are to implement differencing algorithms for some of the remaining fields. So most of the categories have got the differencing algorithms. The SIC needs its differencing algorithm, and the job function needs a differencing algorithm.
Okay.
And I think that's nearly done with the differencing algorithms then. And then this afternoon I'm going to be working on adding the weights.
Oh, right, okay.
Just seeing, I'm going to start sorting them, and I'm going to see how I can add like sliders and stuff to tune up and down the weights.
Right, okay. Friday is when we'll actually extract some data based on the weighting and the model, and then we will send to that campaign Friday afternoon and see what the open rate is.
Yep.
Okay, all right. I'd like to just show you what Joseph's been working on this week for us, and try and see whether or not you would define that as at least narrow AI, okay?
Okay.
I'm going to step out of the way and I'm going to let Joe talk to you so he's got full camera.
The task is we've got a database with 700,000 emails in it, and right now when we need to send a campaign, we look for if one column is just equal. But we want to apply AI to this by taking previous open lists, so people who have opened our campaigns, and then use the data from that to pick out more people from our big database. Yeah, so what I'm looking for is just any maybe advice on how we should just find similarities between records in a artificially intelligent way, sort of. So, because we looked at Amazon SageMaker and we looked at IBM Watson,
Then we can't hear him.
but we've decided that it's quite complex stuff, because I've only got a week to do this, you see. I don't have loads of experience in that sort of stuff, so this is why we've kind of gone with an idea where it's all written in Python, it's all very basic sort of stuff, but we're still trying to apply machine learning concepts to it to pick out similarities.
Okay, so the problem space that you're describing here has considerable range, and I know only little parts of it. I'm a generalist because you're all the way from basic Python programming up to using IBM Watson, and that's huge. How you do that at those different levels is different, right?
We have a large database, and we've been sending to that database for about a year for this particular client. So we've kept a list of all the people that opened the emails from the last year for this client, and we're hoping to train the algorithm using the openers so that we don't have to send to everybody anymore. We're hoping that the algorithm will tell us who to send to that will open the email instead of sending to everybody.
Okay, that's helping a bit. And then you've written a fair amount of Python there already.
Yeah.
That probably took you longer than a week.
That's what I've written in the past 2 days, so 3
okay,
days.
well.
Yeah, yeah. So I've got until we're sending.
I can't tell you whether it can be done in 2 days or not, but I can't tell you.
No, yeah. The thing is with TensorFlow, the way I kind of, I've not really seen many things where it's kind of finding similarities. I've more seen classification, and I know there are ways to see similarities, but it's not immediately evident which kind of like network structure I should be using for the neural stuff.
But isn't this exactly the classic machine learning case? You have these parameters, one set of input parameters that you're training, because you know which one, the cases that match to the output you want. The output is this email was open.
Yeah.
Yes or no. And
Right. So it is
you have all your
binary
input
thing.
parameters.
Right. Yeah. I didn't think about it like that.
Okay, do you have any other questions, Joe?
I think that's it. Thanks. Yeah, that's fine.
All right, well, we, even though, despite being interrupted by your fire alarm, I appreciate your time on this project. It really does mean a lot to us, and we will send you a copy of what we've done here as well. And it would be great if you could have a look at it, and we'll also talk to the schools, and we'll come back to you on that as well. Yesterday we had a call with Peter Scott, who is an expert in the field of artificial intelligence. I think that Peter's probably had about 30 years with NASA in one way or another working in this area, and we went through with him what it was that we've done, and he gave us some comments, and one of those was to consider TensorFlow, which I'm not familiar with, but Joe was. So, Joe, what was that all about then?
Now we're treating it more as a classifier, so we're not looking for similarities so much. We're training a model on things we know work, and then we're looking to classify other things to see if they work. So we're treating it more like a classification problem now. So we've changed some of our columns so they fit better into TensorFlow and stuff, and now we've worked on integrating that with our database. So you define your inputs and you define your outputs. And in our case, we have several inputs, which could be like our employee bands, our turnover bands, and all that. And right now we just have one output, and it's a 1 or a 0. It's a binary classifier. And the neural network is the kind of, we train a model on this neural network which can then take these inputs and predict what the output will be without needing to code any math or anything with this input.
So what's the plan for today then?
This morning I'm going to be working on integrating TensorFlow with our current code, and this afternoon I'm going to be working on starting the training process.
Okay,
Yeah.
cool. And what is this running?
Well, it's running just our Python script
Against a sample of...
against
so,
100,000 records from our database.
So let's say that those 100,000 were people that had opened an email.
Yep.
This here is identifying
The most common demographic that we've hit, yeah.
And then how does the weighting affect that?
So if we notice, then we're going to take this, and if we notice a big variety in one of the fields, we can stop the algorithm from excluding people based on that.
Right, okay.
So it's just stopping people from getting excluded from emails that could be relevant.
So we reached day 5. It's the last day of being email movers.
We did.
So I'm just going to ask some real quick questions.
Although I'm tired.
Yeah, well, we're all tired.
My head's done in now. I need
Yeah.
to go home.
Yeah, well, I mean,
Finish.
just quick video. I mean, this is just to update everybody on the on the journey we've come doing this AI. So, what do you think? So pretty much, what was the topic that you wanted to do this week? What was the goal at the end?
Yeah, go for it.
We wanted to improve the open rate of email campaigns we sent out using artificial intelligence.
Yeah. So, do you think you accomplished what you set out to do?
I mean, we won't have statistics about the open rates until we send out the campaign.
Well, yeah.
But in the end, we did write an application that did take in the open list of previous emails, it took in our database, and it gave out emails that it thought would work, which...
So, technically, yes, it has
the
worked.
application, yeah.
And you've done that in a week.
Yeah.
It's just been 1 week, and we've managed to do the whole thing. So, what changes did you make, if you did any? So, what changed than you originally set out to do? Have you changed anything?
We pivoted in technology quite a bit. So
Uh-huh.
we started out looking at cloud solutions, and then we decided to go for an in-house solution, and then we attempted TensorFlow.
Yeah.
But we didn't have time to pre-process our data in a way that made it understandable to TensorFlow.
What about you, Dad?
So yeah, I think that we got to that point, I think, where we realised what we were doing was good, smart coding, but it wasn't AI.
Yeah.
And TensorFlow gave us the opportunity to access a neural network which could really have added some razzle-dazzle to the whole project. And we just couldn't get it to work because there's just not enough width on the database. So we had a few discussions last night, about how we could hash some of the records in order to add width, but there was no point trying to do that in a rush today.
Yeah.
So yeah, I mean it's not AI as I know it. It's not AI as we know it.
Well,
but
it's
not bad, Jim.
Yeah. So if you could have made any changes, let's say you repeat this week, what would you have done different?
That's a great question.
Yeah.
I think it would have been wise to maybe... I mean, we should have got the data earlier.
Do you
we
think?
kind of started writing the application, we didn't have full data yet, and it's a bit of a hodgepodge when the data came in, and we had to change some of our application so that it would work with our data. And if we had done that, we probably would have looked at the right technologies from the start, so we probably would have gone down the TensorFlow route.
So do you think if you had 1 more week or longer, you would have been able to complete your original plan?
I think we have completed the original plan.
Yeah.
But I think we would have completed it with more AI
Yeah.
if we had additional time, yeah.
Okay, so unless there's anything else you guys want to say for the end of the week, you've both enjoyed yourselves, right? Dad? Yeah? It's been good fun.
It's been a learning curve, and I've loved working with Joe on it. It's been a lot of fun learning about how the whole thing... We know more about AI now, don't we?
Yeah,
I think
a lot
than
about
what
AI.
Yeah. Well, we know more. I know more. I certainly don't know a lot about it, but I know more
Yeah.
than I did. And I guess it's
That is the goal, really, wasn't it? By the end of the week, we just kind of want to learn about it more.
Yeah,
And
yeah.
under- in
it's
general
a-
understanding.
project, yeah.
Yeah.
Yeah, and what has surprised me is it's required a lot of natural intelligence. So,
Yeah.
you know, people with natural intelligence have got to find a way of working together to create systems. Even though those systems are using artificial intelligence, it does, you know, comes from natural intelligence, or that there's nothing.
Yeah. Okay, that's great. Awesome.
Okay, man.